Hello. So we've shown how tessellation and instancing can be used to kind of to render a variety of different characters, but that variety was limited because displacement mapping is limited because displacement displaces the vertices along the normal, and that's limited. For instance, if we wanted to try to represent a woman from this base male mesh, it would be very difficult. It wouldn't look very good because you'd have, like, suppose a woman has a belt and you'd have to displace along the normal to get her width because a woman will have wider hips, and you have to displace along it another direction to get the thing, and that's not, you only get to displace one direction. So to overcome these limits of to get greater variety in our geometry, we're going to try to extend instancing with vertex pulling, okay, to get like a multi-mesh instancing deal. And to do this, we're going to introduce the concept of differential meshes. Differential meshes are meshes that are related. They have the same topology. All of them have the same topology, and they have the same number of vertices. Okay, so consider this base male mesh. Now let's consider a female mesh. This is a female mesh that I got from that base male mesh just by moving and transforming those vertices around, and stretching and shrinking and moving things around. And it has the same number of vertices. The normals, of course, will be changed because when you change those, when you move the vertices, when you calculate the normals, that calculation will be updates the normals and the tangent vectors. Okay, so I'll start from here, and I'll take this woman's head, and I'll be able to bring it into ZBrush and do some sculpting and painting, and I'll be able to get the normal and displacement maps and color maps out of it, and then bring them into my game engine. And the idea is to be able to render all these different types of bipeds in one draw call. Okay, this is Vincent Burnett again. Now we've done the sculpting, we've done the painting in ZBrush, and we're going to bring those texture maps in here and use them for the displacement and the color and the bump map. Okay, okay, here you're going to see the color map, and the one we added in is this one here.
The normal map
Now, if you
is
want to
right
see
here.
the displacement map, then you'll need to go to the domain shader, and you can see it here, and it will be on this is the corresponding displacement map for that, the sculpting that we did. Okay, so we're going to use patches. If you don't set the patches, and if you try to render it as a triangle list, it will give you an error and crash. It'll crash your video card. Okay, so here, let's build this material. Now we've got to go in here. We got to create a actor flex buffer. What we're going to do is we're going to first put the hierarchies in here, and then we're going to use this man reference material. In other words, any object that uses this man X material, it will use this actor flex buffer, and it will and the actual buffer that the material that this flex buffer will use is this material here. It's the man differential flex. Okay, so let's upgrade these to about 1,000. Let's go differential, and then let's build this. Okay, so now the flex buffer is built. What we want to do now is to create a bunch of agents all at the same time. A bunch of these actor objects. We're going to create gain units. And in each one of these units, we're going to make it so that they have like 100 troops in each unit. And we'll create like 10 of those. So let's go here. Let's put a big X. Oops. What you can do is you can just go up here, and this should save time, and just go drag and drop it. Okay. And what we want to do is we want to do these render variable maxes. And the max one is going to be like... Okay. So we created the man agent. Now let's create a woman agent. No, she already has the man X material. So we want this woman to use the fourth displacement map number 4. So we set our min and max values of surface 3 to 4. And the other values are the same as the man. Okay, so we've created that. Now let's go here and let's add a woman. And we want to put about 50 women. And about 50 men. Create this player type. Okay, so we've created 108 different agents, and they all kind of have different variations. Note the men have more possible heads. The women all have the same head, but they can have different shirts and stuff, pants and arms. Let's do something with the get a little ambient lighting in there. Okay, so all these are being rendered in one draw call. We got 100 there. We can sorry, we can move them all. Yeah, those animations are not that good. I did them by hand, and I'm not a really great animator. Okay, so let's create some more. Every new unit I create, all the agents in it, they're all rendered in one draw call. So it saves a lot of time, and it gives the CPU extra cycles to to do all the frame updates and stuff. So what do you have there? I got 700. We got 800. Okay, there's 1,000. It's 1,000 actors rendered in one draw call. That saves a lot of CPU time. That extra CPU time can be used for AI, physics updates, and a lot of other things. Of course, one can use more differential meshes to provide even greater geometric variety.